Okay, we should be live here. Plan for today is to continue on this rocket landing end. Oops, support request. Uh, Gymnasium. Hmm. Yeah. Okay. Yeah, what we're gonna do, let me show this. Plan for today. I was working on this rocket end. Let me just give full context here. So, David Hobb retweeted this thing, or tweeted this thing. This is an old, like 7-year-old environment, completely dated, wasn't usable. I got it running with rendering packages that actually compile. I got it into Puffer. It's like 100x too slow at least. So we're porting it to C, and we're going to see what we can get done on that today. The actual code for it is very simple. The physics engine is a total pain. So that's what we're going to try to figure out at the moment. Oh, and then also, this is the last day I'm just going to be doing this yesterday, today. Hopefully we can get pretty far on it. And then the plan is over the weekend. Where did this go? We had a PhD candidate who wanted to jump in on this. Yeah, so had a little DM thread with this guy, and he'll probably jump in over the weekend, so then hopefully we'll have this shipped this weekend. But my goal for today is to get it into a sane enough state that we will be able to do that over the weekend. Let me show the current version, what I've figured out with it so far. So this is in the pure C API of the physics box 2D thing. So I have the rocket. You can see these are the landing gears here. There is physical simulation on them. But mainly the thing is just the coordinate system is really weird. And I'm having difficulty figuring out how to like attach joints at the right places and stuff like that. Okay, so here are the legs. And kind of weird that this is not the right position, right? Let me see. Well, hold on. This could also, there can be a rendering error here as well, I think. Let me see. Because I'm giving, hold on, I give extent. No, I give extent correctly here. And then the thing is that I'm not rendering. There's no like a built-in render. I'm doing my own. So it's possible that I have this wrong. I think this is getting the middle a bit, right? Hold on. We're centering this rec width over 2. Position. I actually don't know if this is correct. I'm trying to think if I want to make like a little sample program. Just to make sure I'm doing ArrayLib correctly. Is that worth doing? Because, yeah, I actually don't know if this is the rendering or the physics sim. Yeah, let me just do that real quick. So, like, here. This is main. What we'll do is window, set target FPS, begin drawing. Let's start by rendering like a box of some variety. Let's say we're gonna do this at like 500, 200. Okay, so here's our rectangle for testing. And then we need rect to origin, rect dot width, and then we draw rectangle origin. Let's do like okay. We also need to do a circle at 500, 500, I believe. This color is just like blue. Cool. Okay, so what happened here? We drew Is it in degrees? Well, first of all, I think the rotation is in degrees. So let's do 45 degrees. Okay, yeah, so this was in degrees. But then I think we do have centering working correctly because we put this at 50-50 and then we centered it here. 500, 500. That looks good to me. And how do we do it up here? So you get, this is the middle point, width and height. And then this is in radian, so we do float degrees for pi. I. Oh, this is what degrees to radians was for. So then what we do is we put degrees in here. Let's see if there's anything else I'm missing. No, this looks good. Because the origin at half, yeah, this is the same. Alright, well, let's see if, Test. Let's see. I think today is just going to be like focused, chill dev stream. I really would like to get this thing into a good spot. What did I do? Is this already defined by math or something? Yes, it's already defined. Okay, so here we now have this thing falling. And then whatever the heck that just was. Let's see why this would be wrong. Initial y. What do we get on initial y here? Okay, so initial y is actually puts them in the middle. It looks like. Interestingly, so like the legs are now centered halfway between. So I'm definitely not understanding something. Oh. Yeah, okay, it's because it's all from the center, right? So it should just be... I think I understand the coordinate system now. Yeah, I understand it. Okay, so we have the position. Extent. Oops, did this not build? Where is it? Leg. Okay, so this is now correct looking. It's still like not perfectly matched up, but it's very close. And that could be the physics, yeah, because it's changing over time. Perfect though. And now we have to figure out the joint definitions, I believe. So what happens when I just uncomment this? Actually, hold on. Why isn't it rotated? Why don't we see rotation on any of the legs? There's no rotation here, right? What about... Can we do... Is this degrees? We might not be rendering rotation. Hold on. Let's render. Height. Degrees. Okay, so here we can see we have some very small rotation in degrees. Very small rotation degrees. This is supposed to be divided by. Yeah, there we go. Rocket ship. Yeah. What is this? Leg away. I think I just overtuned this, didn't I? Oh yeah, this is just a tune parameter. That looks a bit better, right? Yeah, there's the physics. Now we have to attach these together. We have to figure out the angle joints. We figured out the positions, though. What's going wrong there? So now, oddly, when I attach these things as joints, they get attached up here. And whatever the heck has happened is causing this thing to... is causing this to fall over. Let's see what happens with this. So, when you attach... I wonder if the position changes contextually based on the fact that it's attached. What if I just do 0, 0? What happens? Falls much faster, which is interesting, at least initially. Yo, welcome. Been a while. How's it going? That's weird. What's up? We are landing rockets now, apparently. I don't know. I saw this, like, sometimes I just see stuff online and I'm like, oh, I gotta do that. And the impetus for this was... Where did it go? This rocket sim here. So we got this one working, but now we're putting it into C. And the C stuff, well, the C is easy, honestly. It's the frickin' physics API for this. It's a pain. There's a lot of cool new stuff. I don't know if you've seen. Look at all these environments. Applying for grad school, best of luck to you. If it's in the US, hopefully you've gotten GREs and stuff underway. I remember when I did my PhD apps, I literally like decided I was going to apply, studied for, registered for, and took GREs in the span of like 2 weeks. Grad school a throwback for you? Not really, to be honest. I'm way, way happier doing this stuff now. Like, yeah, I'm gonna have some troubles, like, with some stuff on business side of Puffer. It's gonna take a little while to get customers going and stuff. We've had some likelies, but overall the work is way more interesting. And I'm in a position where I can kind of just chill and do this stuff for a bit. Ace GRE. I think I dropped 2 points on math and perfect verbal. That's nothing to brag about though. Like it's like a very stupid test. It's like one of those very stupid tests where it's like you have to the main thing is just being focused for that amount of time and not being like not making careless mistakes. It's not like a hard test. It's like high school math. Honestly, I probably wouldn't be able to do it now though. I haven't done any math in a while. Hey, have you been doing? It's been going pretty well. Landing some rockets. Waved by a lot of unis. It's probably for the best. It's really a waste of time for anybody who has any business applying anyways at the top end. We definitely waste way too much of people's time in their 20s. Like if you're gonna waste time in 20s anyways, you may as well be having fun. I would like to understand this joint def thing here. I don't understand how this is influencing the position system. So like here, if I do, I'll show Ramsey what I'm doing here. So like, watch this. So we have this rocket. Looks fine, right? But then if I attach the joints, if I try to attach those things, because the landing gear is not actually attached as a joint, then suddenly it jumps to the middle of the ship like this. You still recommend CS231. It's not an RL starter, it's an ML starter. That's the best starting point for ML, yes. PufferLib would speed up a custom robot RL11 that's CPU based? Absolutely. Absolutely. And for RL, there really isn't one. There's not like a course. I never took a course in RL. You have to, there's a handful of papers you should probably read and like a few repositories you should play around with, and then you should just start like doing stuff for the most part. Like when I'm getting into a new subfield, I read a bunch of papers and I play around with a bunch of stuff. And then as you get more experience in that subfield, right, you read fewer papers and you do more of your own work because you're confident that you have a good grasp of the surface of things that you know and that you don't. And you're usually not wasting time doing something that's already solved. Local anchor. I don't understand the positioning of joints here. I think there's a box 2D thing on this. Not Python. It's in C. Even Robotics M uses pub sub. Huh? That is a bizarre design for an environment. Like, what? Puffer is generally going to be faster than, like, your Gymnasium, SP3, whatever equivalents. Like, we just have optimizations that those libraries don't. What are you building now? Controlling landing, rocket orientations. You're controlling the landing. Or the... So it's just, the thing is that I'm trying to port this rocket environment that was written 7 years ago by some random guy. He wrote it in Python. I'm trying to port it to C. Because I've got it working. I got his old code working in Python and it's too slow. And the physics engine he used actually is written in C. So I'm just using the C API instead of the Python one. But that's actually very hard because the Python API is very, very different from the C API, and the docs aren't that bad. That aren't the best. But I'm figuring it out. Yeah, I don't know exactly what you asked there. I mean, but this type of work is stuff that people can absolutely just do. Like, the background for doing this work is straight engineering, right? Like, you don't really need to know much RL to be doing at least what I'm doing right now. Yeah, to know how everything fits in context, and how to optimize stuff for RL, sure. For what I'm doing now, this is just straight engineering. Okay, so you have body A, body B, and anchor. Body utility functions to simplify this. Oh. So... positive, measured in radians. I think it makes sense picking up problems such as these. You can only truly learn by building stuff. Well, the thing that's useful is you need to have a mental model of, like, what things are already solved and what things you know and what things you don't know. That comes from reading papers and being familiar with literature and being familiar with a lot of the stuff that's out there and how people are doing stuff. You have to have the big picture. Like, my iceberg video goes through a lot about how I'm thinking about reinforcement learning right now and why I'm doing what I'm doing. I have a very clear picture of why I'm doing what I'm doing. Of course, like, does this specific rocket amp need to exist? No, this happened because I saw something cool yesterday and thought, okay, that would make a good RL env, and maybe some people will like this. But I do have overall a model of what I'm doing with Puffer, and I'm very confident in it. What is this? Local anchor. Anchor point is specified in local coordinates. You can use body utility functions to simplify this. Okay, but this is local chord. RL advanced a lot since you were introduced. Reading papers, and so on. That's what you do in any scientific field. Like, yeah, that's what you do in any scientific field. You don't have to go too crazy on the papers, but you do need to get a grasp of, like, the pivotal work. pivotal. This is very weird how this works. Nothing about Puffer or RL. I'd like to dive in. Where does somebody like that start off? Well, you start off by, like, look. Here's PPO. This is like the most widely used algorithm that has solved Dota. It solves Atari. It solves like tons and tons of different things, right? The whole thing is 325 lines. This is not importing any other garbage. 329 lines. The rest of the stack underneath this, for like environments, parallel stuff, and whatever, Puffer currently has that in maybe a couple thousand lines. Like, you can literally just read the code. And then there's a paper, you can go read the PPO paper, you can do this for like a couple other things, and you're already off to a good start. Like, literally, you can have your start on the field today. Like, not next week, not in like over the next 3 months. Like, you can literally have that done today. PPO is, well, you should probably understand where it comes from, and there's a little bit of history to what got to there, but yeah, like, we're using PPO by default in Puffer. There's more complicated stuff out there that has some application, but like, a lot of these things are not very long, right? This is true of a lot of things, right? If you just don't try to, like, if you actually look for the simplest possible way of doing something without all the fluff, like, this is true in language models and such as well. Like, you can implement transformers from scratch, not using PyTorch, in a couple thousand lines at most. And people that actually care about doing that stuff are very good to learn from, right? Like, if you wanted to really understand transformers and such, you can look at like Karpathy's Nano GPT. The only thing that takes much, much longer to like really wrap your head around is, I think, just good programming and software engineering in general. That's the thing that I don't know I don't know of shortcuts in that space. Like, engineering just feels like software engineering, it just feels like a space where you just have to have been doing it. You have to do it for a very long time. You have to make lots and lots of dumb errors, and eventually you stop doing things in ways that are completely dumb. Or at least you do it less frequently. Moving components, IMs, models, agents, actual. Yes, but like the whole stack of all of that can be a few thousand lines of code. Having no compute. It's not a deal breaker, especially with our new environments. Our new ones will run at like hundreds of thousands of steps per second, even on a laptop. It does help to at least have a basic desktop setup. This is something I try to help out with some of our contributors. Like, I just onboarded a new like open source contributor who made some environments. I said, okay, you've been doing cool work. We'll get you one of these machines, and we'll get you access to one of these. This is going to get built out over the next year or so as well. We're going to get more of these. Really, really want to have this field be in a good spot. I'm investing personally in doing that. I don't understand this joint def. It's in local coordinates. I don't understand how the positions of these joints are passed. World pivot. Local anchor A. It takes the same point on both. How long would it take someone to get in? No. We had somebody join like 2 or 3 weeks ago. It really is more dependent on your engineering experience than anything. Like, here's like the most recent of these is Spencer just joined, like, what, 2, 3 weeks ago. Spencer built these two environments, right? I did a little bit of work optimizing them and getting stuff nicer for web, and now he's got 2 environments and a new one that he's building now. Nathan built this Pong env and is working on a new one. Noah built this breakout env. There's this TCG that's going to need contribution on. It's really just dependent on eng experience or how quickly you can learn there. Hey, Tim. Reading up on PPO, what parts does Puffer take care of for devs? Everything but the environment specifics. It's everything but without a bunch of layers of abstraction, Tim, if that makes sense. So, like, here's clean PufferL. This is our main train demo script. It is like cleanRL, so all the implementation details are in this file. You can edit them, you can mess with them. There's not like a bunch of stuff hidden from you. But this is also, like, in 600 some odd lines, one of the fastest and most flexible implementations out there with tons of logging and perf optimizations, etc. We have similar stuff at the env level, simulation level, and so on and so forth. OpenAI said they use PPO exclusively. They don't really do like RL in the sense that I think about it anymore, that I know of. Yeah, PPO is very nice though. It's a very simple algorithm that works very well. And like it works well enough that there really has not been compelling evidence for more complex methods replacing it. I mean, if you have not seen my iceberg video, this is a 26-minute video in which I go through all the different things of RL and Puffer and what I'm doing with it. It's on the YouTube and also on my X page. Can you break it down how these individual components, EMS models, where does Puffer come in? Did you see my iceberg video? I pretty much do that. Like, I go through the entire stack. Like, the thing you have to realize is that if you actually build this stuff with an eye toward simplicity, like, all these different components end up being a few thousand total lines of code. It's not a lot. Yeah, definitely watch that iceberg video. It'll give you a lot of perspective. Like, what Puffer does is Puffer basically polishes all of these different components up and makes them play nicely together. Like, if you look at the algorithm, okay, our version is simpler, faster, and has better logging, right? You look at, like, parallel simulation. Our version is simpler, faster, more flexible, and actually 10 times faster in some cases, right? You look at our environments. Okay, we have first-party environments that are like 1,000 times faster, and then we have bindings for lots of existing EMs that aren't 1,000 times faster, but are much faster than anywhere else, as well as less error-prone, right? It's basically just systematically going through every single component of the RL ecosystem and just trying to polish and simplify and speed up. There are a few researchy type bets I've made as well. Like there are a few things that we're pushing forward more fundamentally at the same time. A lot of it is about simplicity and speed of everything in the RL ecosystem. Welcome, YouTube folks. Good time to mention that all of this stuff is available on the GitHub, PufferAI, PufferLib. It's all free. New stuff is in dev. If you want to help me out a ton, just start the repo. Helps me out a lot. I'm rather confused just looking at this joint stuff in the background. I think I am too. I think we are going to completely revamp this field. It's almost guaranteed at this point. It's a lot of work, is all. And we could use more people building these environments and helping on that side. Really just takes good engineering background more than anything. Like I don't mean like big, big systems engineering or anything. It's just like environments are a few hundred lines of code. It's just simple low-level dev. And occasionally fighting a dumb physics API like I'm doing now. First need to understand our ecosystem. Puffer being an optimizer. It's not like an optimizer in the sense of an algorithm, it's an optimizer, but we do a lot of optimization on all these components. Watch the video. Like, I put a lot of effort into that video. It's like that's production content there. Like, I literally made that thing to link to people when they ask me this. I spent like a good 2 weeks, 2 weeks like scripting and editing and like filming that thing for reference. Yeah. What the heck is wrong with this thing? Like, I don't define joints. Is there something at the top that tells me how these are positioned? Defined by anchor points. And how do they do the position in the C code? Or no, the Python? Too many tabs, hold on. So in their Python code for this, start checking out right now, read up on PPO. Yeah, it's like you literally just have to do it is the main thing. It's like best time to start learning something is yesterday, second best time is today. It's that simple. Like literally just doing that puts you in the top 5% of people like asking me about like getting in AI or doing, stuff in RL. It's literally just like the people that want to do it do, and they just like they put in the effort to learn. It's so much easier now as well to learn than it ever used to be. Like, you want to know how rough it was 10 years ago trying to learn AI? It was not fun. You know, you want to know how much rougher it was probably like 10 years before that? I don't even want to know what those people had to put up with. So much easier now. So they make this joint. Leg gets initial X, initial Y. Do these things get attached? Hold on, just put it in global coordinates. Good luck with physics, API, try to catch next stream. Thanks, yeah, see you around. I think maybe what's happening here is like I'm looking at this joint and I'm looking at this leg, and this leg is put at initial Y. Right, this leg is put at initial Y. And then the anchor point for it leg down. It's so weird. Are these supposed to be different points? Oh, wait, these are supposed to be different points. That's what's screwing it up. Yeah, that's what it is. So, the thing I didn't understand, I think I figured it out. The way that joints are defined here. You have this local anchor point. This needs to be B2 get local point. And then what you just have to do here is you just have to figure out where in the real world, where in the world you want the actual point to be at. So if this is lander ID. Oops. And then this is going to be leg ID. And then we actually have to figure out where this is going to be on in the world, which is do you need to get the same point though? No, you just need to find one. You have to find a point in the world. So we could just do like leg I times leg away. B2 body get local point. Don't like the way that this works. You need to figure out like precisely mathematically where this thing goes. So I mean this is probably like, I mean, maybe I can find it. Float lander leg X, joint X. This is going to be, you take lander width over 2. So this is going to be leg I times, so this gets us negative or positive. I think that is literally it. And then we do, they have to overlap though. We'll see. So this joint Y is going to be initial Y minus lander height over 2. Let's just do world joint pause 2 joint P. This is actually B2 back 2. Okay, and we get this position. Then this is going to be joint P. And let's see what this does. Unused, that's fine. Oh, okay, look, something actually kind of did something. Curious to see what happens. Oh, look. Something tells me these aren't attached. They're definitely connected in some way. That's real weird. Bonk. What I don't understand is how the joint affects the position. I don't understand why setting the joint anchor affects the position of the things it's attached to. Like, how did he do it here? He did... I guess he probably just did some math here to figure this out. I was playing with PufferLib on custom multi-agent and for airplane collision avoidance. Cool. That seems like a reasonable use case. YouTube sometimes clips stuff. Really don't understand why moving the joint affects the position. Tries to satisfy the constraint by adjusting the positions such that their respective attachment points, the point on each body that corresponds to the anchor, match the specified anchor position. Oh, that's gross. Hmm. Okay, so it is wrong math, but it's handling the math in a very weird and unintuitive way. I see why he did this in local coordinates then. Let me see, so he did -I, 3 lander constant. Like W, like H. I don't understand this anchoring. I don't understand this anchoring. I want to understand how the heck this is actually valid. So on the lander, it's set to 0. Local anchor. This is in world coordinates as well, isn't it? Unless this is changed. YouTube might be eating your messages, by the way. I'm not seeing anything. Just figure out how this thing works. You have side thrusters. How the several agents are trained. One model for each agent, one model for all the agents. No, so it depends what you're doing, but the most common use case is that you apply the same model independently to the observations of each agent. So what this means is that you're using all the training data to train one model, but that model is controlling each agent independently, and it doesn't have any knowledge. It doesn't know the internals of what's going on with the other agents. This is the default in PufferLib. Via hidden states. Each agent has its own separate hidden state. That means all agents have the same task. Not necessarily. You can have the same model doing different tasks at the same time. If you do task condition learning, I do that in some of my work. It's very flexible. For practical purposes, you can kind of ignore the fact that the model is the same. People get too hung up on that. Every agent could just as well have its own model. It just turns out that practically that's hard and slow. It's better to just use all the data to train one model very often. This physics engine is kicking my ass. I don't understand how the coordinates are being done and how on earth they're valid. Leg down. Leg away. Maybe oh, 0.3. Yeah, I don't understand this. Okay, thanks. Yeah, no worries. I don't understand this thing. How this leg down does anything. Unless, hold on, does he have... Wait. What's this rocket look like on my screen? No, this is correct. The legs are... Legs are attached in a reasonable way. Lander, yeah, exactly. But I don't understand how this math works out, because, what's supposed to be happening here is that there's an anchor point. I don't even know why he has the nozzle on there as like a physical element in the first place. Like, the legs are kind of janky if you think about it. Like, the physics sim for the legs is kind of just really janky. Like, you get these wobbly legs anyways, don't you? Yeah, these controllers are just very bad. Maybe I should try to do the thrust. I mean, he probably... Let me see how he has this modeled in the first place. I mean, he has this thing modeled as a point mass. L1. L. Maybe I don't even need to mess with the joints. Like, maybe I just need to apply the forces. We should try that, because otherwise, like, this joint API is very janky anyways. Let's try that. Comment this joint stuff. The thing that really matters is not the joints in this, it's the forces. Okay, so here's your physics box thing, right? Yeah, I think this will be easier. So now I have to figure out how he applies forces, which should be... Oops. Where'd it go? Main engine force computation. Rocket part. Action. Side engine force computation. Dispersion. +2 for randomness. Apply force. Point wake. Particles and rocket part. Okay, so literally, this thing has just been vastly complicated because the guy used he used the physics engine for particle effects for some crazy reason, and for joints and like, yeah, I think this will be a bit easier. Fire engine. Where is it? Lander ID. V2 body. Apply force. ID. Force is going to be this. World point. The world point is going to be V2 vec2 loc equals V2 body. Get local point, I believe. Get world point. Get world point. And then this is going to be somewhere on here. Minus. So there should be lander height over 2. Yeah, this is lander. Get world point. Their width over 2. And then lander height over 2. I believe. Let's see what happens. Get world point. Stupid autocomplete. Too few. Oh, yeah, we also have to figure out what this wake parameter is. Option to wake up the body. The force is ignored if the body is not awake. This is true, right? It's like true. Okay. Unused variable P. Nothing's happening. Nope. You can provide a world point. We apply to the center. Is it moving to one side? I think it is moving to one side when I do that. Hold on. Well, look at that. Okay, so something is happening. It's just the units are screwy, right? Oh, yeah. I think I broke it. So here comes the rocket landing, right? Huh? Is it coming back? Yeah. Okay, so it has to be applied in a specific direction, obviously. Let's go figure out that force computation. Yeah, but it's going straight up. This is going to be substantially easier now, though. It's the joints thing was just god-awful. And I don't even think it was that useful, to be honest. Trusty thrust. Alright, so... rocket part dot angle. Box 2D. Simple 2D constraint solver. The original was written with Box 2D Python, so I just went to Box 2D C. It looks like a fairly large and well-maintained project. It's been used for RLMs for a long time as well. In engine force computation here. Okay, so I need to get... yeah, this is what we need. We're gonna do this in the render mode to start with, because it's gonna be easier. Obviously, we'll split the logic out thereafter. Really like the physics demo? Yeah, we'll get these things working. The RL portion is not going to be hard. It's frankly just like the building of this thing that's obnoxious. Like the getting the sim to be... It's not even getting the sim to work, it's getting the freaking physics API to behave. Okay, so here we have world point. We've got rotation, which is going to be lander ID. And I'm literally just going to do B2 back to force equals B2. This is going to be, do I have math imported? Include math. This is going to just be sine. Oops, not this. Then you apply the force, which is going to be float. Alright, so now we just give it force here. See if this does anything remotely reasonable for us. Okay, so we have rocket lander falling. Oh, look. I think we need to have world point. This point P. Px per meter is 1. We should do like draw line. Just do something. Can we see our force line, maybe? Ooh, look at that. Get world point. Oh, wait, this is supposed to be... P.x, P.y. Yo, just back from watching vid, not understand everything. Can I say a lot of things are clearer? It'll get clearer as you learn a little bit more in RL. It's the type of thing that you're probably going to have to watch a few times. Not like back to back, but like, you know, do that. You watched it that once, read a few papers, watch it again. It should really make the space a lot clearer. Like, I spent a lot of time trying to lay that out cleanly. Very weird how this is. Oh, hold on. Maybe I need to convert. Yeah. Y needs to be converted. With Y. Try to train an agent simple Atari M. Atari is really slow is the obnoxious thing. You can use like our faster Pong M or whatever that we've got in dev, or you can use just like Cartpole or something even. Read a few papers. I just like to start with go read like DQN, PPO. Yeah, just read like DQN and PPO. Those are like core algorithms, and then you'll get to read more fun stuff after that. Why is our force vector not showing up? It's also weird to watch an object falling like this. Yeah, look at that. Try the Pong one then. Will I be able to run it on my laptop? So running on one CPU core in my local desktop GPU, this thing currently trains at 300,000 steps per second, 340. We can probably make it much faster than that as well. Yeah, this thing crazy fast. I don't know why we're not getting any stats out of it at the moment. That's not good. Maybe breakout's better. There we go. We do get stats. It just takes a second. Yeah, let me know if you run into any trouble with them. But people in Discord are very helpful as well. Puffer, discord.gg/puffer. When you run the env and you say it's your training at whatever steps, does that mean it's training perpetually? No, what it means is that, well, you have to kind of have some frame rate in mind, right? So like let's say that Pong runs, it doesn't actually have to run this fast, but let's say that Pong runs at 60 FPS. All right, so we are doing 340,000 steps per second. Divide by 60 steps per second. It means you're running the game of Pong at 5,000 some odd times real time and training on that data. That it's playing the game at 5,000 some odd times real time speed. Which is very fast for RL in general, but very slow for Puffer. We should definitely have that at... Well, I guess this is on my local desktop and I'm doing other stuff. It should be at about 1 million on a better box. 1 million steps per second is pretty damn fast. trying to figure out what the hell's wrong with this thing. Oh. I'm actually confused how this is even drawing at all. Very weird. Basically, Atari game runs at... Yeah, for the most part. It's just, if you can only train as fast as you can run the environment. And our environments are fast. A lot of the environments out there are not. Which actually doesn't necessarily have anything to do with the complexity of the environment. It just has to do with the quality of the code more than anything. Well, this is doing something. No idea what. Uh-oh, why is this not autocomplete? Why is this not... Draw entity? Is this not supposed to have a negative sign on it? You get this thing. It looks like it is actually supposed to have a negative sign on it. Oh, wait, did I forget? Got to begin camera mode. That's not very smart. Okay, now we have it. Well, I blew it off the screen, but... Okay, so now we can actually see where we're going to apply force from. It's currently right there. And we can see that where we're applying force from does not make very much sense. I expected this to be... The coordinate system just doesn't work the way I expected it to be. Get local point. Oh, they have raycasts. Cool. How do I get... Let's see. Make box. How do I get... Wait, isn't this... Get world point. Counting for rotation. Accounting for rotation. Isn't that what I did? Hmm. Oh wait, maybe it was just... Oh yeah, hold on. I might just be off by... negative p dot y. This is weird. I still don't understand the coordinates here. Like, how is it getting... I don't understand why... Like, you start out, right? And it's in the right spot. Oh, wait. This is 0 to start with. Wait. Oh, I don't know what the hell happened there. That's bizarre. Okay, so now at least... Oop. And now it goes back down. And we do radians, equals float of 0.1 times let's see if this shifts it now. Yeah, there you go. So now you should get shifted a little bit. And then this starts to freaking rotate for some reason. Well, the force does not get applied in the right spot once it starts to rotate. For some reason, this point there's something happening with local coordinates that I'm not understanding. Rotation. Which is very weird that it's rotating that way, actually, because it's like clearly the right point to get. It's not just getting a point that's below the center of mass. Wait, I could also be rendering it wrong. That's an interesting thought. Maybe this is right and the other thing is wrong. Right? Let's think about that. I think they had some weird coordinate system. Super difficult for bio and for mathematician. This is difficult for everybody because it's just a janky API that's not well documented. I'm suspecting that I might not be rendering the angle the way I think I am. Wait, do radians? Hmm. I'm like almost just tempted to make like a sample toy project with this in order to to make sure I'm actually doing it correctly. Like, you just can't tell what the hell is going on in the sim. Let me see where... Let me see if I can figure out based on this. So, like... Okay. You are actually... I'm trying to figure out basically if there's any consistency with how this is being applied. I just can't figure out the local coordinate system. So like here, this needs to be not so high up. Okay, so now we have a rocket, right? And we're gonna like send this off. What's the cursor click thing again? Where's the damn human client? Mouse button pressed. Okay. I think we just have to flip the Y coordinate, right? The flipping of the coordinate system is really gross. Um, okay, so you have this B2 point. Then we're going to do force. We have to do this. Expect force. I'm trying to make like a basically like a physics toy thing so I can see if these are in the right direction. This is just like a stupid amount of like finicking. I like actually hate this engine. The heck? This coordinate system is going to drive me insane. I have to figure out something about how I can like make the Vrelib coordinate system just be the same. Um, could just table it. Yeah, I know, but it's just like I'm gonna work on this today, and after that, I have a PhD candidate who actually wants to help with this. Um, I didn't expect the physics engine to just be this cancer. If I can figure out a way to at least get the rendering lined up, so I stop screwing up coordinate translation. Maybe? I mean, it's just flipped Y. Really does not play nicely with your coordinates. Let's see what this does. And like, wait, why am it? This should be. This should just be mouse. P.Y. Yeah, okay. Did I add a 0 or something? Oh, it's just because... It's fine. P.Y. Okay, so here this needs to just be 0. What? Dude, what the hell is going on here? It's the stupid coordinate translations between the frickin' renderer and the physics engine that's just driving me insane. That's all it is. Wait. There's gotta just be some sane way of dealing with this, right? Begin mode 2D. Is it just because this is giving me pixels, or... I can just do this. No, I can't even do that because it's, the line is, like, has one frickin' end in one coordinate space and one end in another space. What a god-awful nightmare. Wow, I hate that. I mean, just like, what the fuck? I mean, yeah, everything is gonna just be upside down. And that's probably what's happening with the Y offset. I just don't know how to solve that because, like, what if I just do this? What happens? Nothing. I can't see anything because the coordinates are freaking inverted. What happens? How do I get the mouse position in freaking world space? Does this do this? Okay, hold on. Okay, I was just being stupid. Fair enough. Yeah, and then the angle doesn't get messed up because it's applied to the center, right? Okay, so now what if we do this now? Let's figure out the second portion of this. Yeah, I've just been working on this for a long time and I'm like burning myself on. It's fine. I'm trying to figure out where like you start out in the right spot here, right? Pushing this up, and then as soon as it goes this a little bit, It's like off by a rotation factor. How does that happen? I mean, does the way it's behaving make sense? Let me see. If I push it over here, that didn't work. Wait, hold on. If I push it from here, no, this is not. Okay, it's not behaving the way I think it is, so I assume it's not rendering correctly. Yeah, like the force is backwards on the X. So why is the X backwards? I actually don't understand how the hell it's possible the X is backwards. Unless, oh, that's actually how, the rendering is, like, somehow grossly wrong. I'm pretty sure. Let me think. So, what is wrong with just flipping the y-axis the way I'm doing? Green to world. No. It's very weird because this is like... So I push it up here, right? It looked like I pushed it that way, right? Maybe not. Push it this way, push it back. It looks to me like you're pushing it from the bottom here when it says you're pushing it from the top. What's this? Do I have to invert this thing? The Y literally shouldn't matter if I'm at a horizontal, right? If I like do this. This has nothing to do with linear algebra. This has to do, yeah, it's like, sure, you can say it's linear algebra, but if somebody just fucks with your coordinate system in a way that you don't understand. This is not just me being bad at math. This is like the coordinate system being screwed in a way that makes no sense. Isn't this gonna draw the wrong way? That would do it, right? Wouldn't this do it? What happens now? Hold on. Like brain-numbingly obnoxious. You flip the coordinate system. I want to draw up. Can't draw that direction. So I have to do... That doesn't seem right either. this is not right. Just like so confused with this bullshit. So what do we have here? This goes to the top. What do I... I mean, the fact that it is mapping to the correct chords. If you simulate many concurrent jobs with physics, you just speed up the time to make them faster? Yes. How does fast RL work with physics that depend on time? Yeah, you don't have to simulate physics in real time. There's no link whatsoever between the time that the CPU is running at and the time the real world is running at. That's not a problem. Literally none of that is hard. None of the physics here is particularly complicated. Nothing here should be remotely hard. The only thing that is obnoxious right now is this coordinate system with this renderer and this physics engine making no sense. The RL problem is trivial. The physics problem is trivial. Everything is trivial. This is pure technical stupidity. Which is why this is so infuriating. What's going on here is that in the renderer, down is up and up is down, right? So when you try to render shit, you have to do some adjustments to the coordinates. Pretty basic, right? Except at the same time, I don't know what's going on with the renderer, because the renderer is switching between, not the renderer, the physics engine, because it has like multiple different local coordinate systems and a global coordinate system where up is up and down is down. And basically between all of that, we're just fucked. That's what's going on at the moment. And I don't know what to do about it, frankly. Damn, I would switch to it. Yeah, but like what? Rewrite in pure C. What do you think we're doing? This is rewriting it in pure C. Literally what you're looking at. Welcome, Jake. Losing my mind here. I would switch to it. Yeah, fair. But now I've got a cool PhD candidate who wants to use this thing. And like, this is such a stupidly simple problem to give up on. Like, I can't express how trivial this problem is. Like, I could make this thing 3D if I wanted to, and add a couple other thrusters and like some wind just to screw with it, and it would still be easy for RL. RL is really good. And Puffer is very fast. Where's this force getting applied? Apply force. What coordinate system do forces get applied in? Do we know that? Provide a world point. Just talking about this coordinate system, Hal? Yeah, well, it's like you're gonna get this in anything because, like, most of the time rendering this way's down, and then physics this way's up, and like it causes many more problems, right? Weren't you rendering it properly yesterday? What happened? Yeah, it's fine in Python if you want to train your environment at like a few hundred or a few, like, couple thousand steps per second. I mean, that's just not a useful simulation. Like, it may as well not exist. Like, the thing that happened here, and this is why, like bad engineering is just so freaking painstaking. Like, there's this big library, Box2D, right? This physics engine. It's been around forever, and they have a Python binding for it. But the thing is, the Python API is completely different from the C API. So it's incredibly difficult to translate because, like, nothing remotely matches up across them. A sec. Wait, is this part of Raylib? Does Raylib have its own physics? Is this independent? This actually looks good. This is not by the same author, though, that I see. Rayson is here. Not one of their official ones. Yeah, but, like, I'm not sure I trust it. Like, that, it doesn't make sense if you think about it, right? A physics, it shouldn't have to be tied to a render library like that. If I can just figure out this one coordinate thing, it shouldn't be that bad to just get something at least. I don't understand why this vector gets out of sync. Get world point. On the lander, this is taking into account rotation. This is the top of the lander, right? So this is, no, this is the top of the lander, bottom of the lander. This is now bottom of the lander, right? No, hold on. So now we have bottom of lander. The fuck? Oh, hold on. Okay. Why is this? Minus lander height over 2. No. Something is wrong here because that's up. Up left corner. This gets the center point. Counting for rotation. The center point instead. Is this even the case? Yeah. Rectangle. How does this even make sense? Well, hold on. This one makes sense because of the rotation, right? Orientation. Ferox also using Raylib. I'm gonna have this problem anyway, like lander height over 2. Cause the red line to point towards the bottom left of the bounding box. It's not just the bottom left of the bounding box. It frickin' rotates all over the place, right? Yeah, look. You see? That's not the bottom left of the bounding box. I don't know what's happening is the thing, right? I don't even know what the transform is or is wrong. I don't know if the rectangle's drawn correctly. I don't know if I don't know what is wrong with it. Like, because there's, like, some coordinate shenanigans. It could be the local coordinate system. Like, there are too many coordinate systems going on for me to know what's happening. That's some cursed. Yeah, I know. This is actually driving me insane. Like, this has been the least fun day I've had in a month, at least. And that includes, like, 4 meeting days and 100 degrees. But I really do want Puffer to have some physics sims. And, like, there aren't any because people use the frickin' Python bindings to these things, which is like, it's calling, like, this little tiny piece of C code in a loop a million times a second and wondering why it doesn't work, right? I've been, like, trying to think if there's a way to just flip the Raylib coordinate system. I can't think of one, though. Want to mess with that. Like this negative lambda height over 2 should be the top of it, right? Or actually, put space, we're at the bottom of it. And then if we do like this, we're at the top of it. Lambda height over 2. No, wait, because up is positive. This is actually correct. That is actually, this part is correct here. And then, let's see. Okay, so then, is it rotating the other way? It feels like it's like rotating the other way. Like the rotation backwards. Oh, fuck. Yeah. Uh, I know what it is. That's so obnoxious. That's so incredibly obnoxious. Holy hell. Uh, the problem is that when you flip the y-axis, you flip rotation. That's the problem. That's what it is. That's why it doesn't make any freaking sense. You flip the y-axis, you flip the rotation. Okay, I've like completely fried my brain here. I'm gonna take a couple minutes. I'm gonna get myself a cup of tea. I'm gonna use a restroom, and I'm gonna be back. We cannot deal with this. I'm trying to think, like, we're gonna have to find something where we don't have to deal with this. Because this is just so incredibly ridiculous. Be right back. Yep. I honestly can't even be that mad. It's like, I should have thought of that. Why does it not... Hold on. Why can I not... Oh yeah, you can push it. It's just difficult to get it in the right direction. There's your physics engine. Freaking rendering working. It was the rotation. Because I flipped the y-axis, I also have to flip the frickin' rotation. But, like, you gotta realize, I didn't even know if it, like, it was, yeah, rendering. It was not even... It's not that the force was wrong. The math was right. The rendering was rotated the wrong direction. It was just a really hard to see symmetry. God. That's god-awful, though. Well, I mean, the good news about this... let me go get my tea. I think that was the worst part of it. Now, I'm, like, way more exhausted from that than I should be to finish the rest of this, but, like, hopefully we can get a reasonable little prototype since I got that to work. I'll be right back, and then we're gonna add side thrusters, we're gonna add some stuff, and we'll get it into an RL environment, and we'll see from there. Okay, here's what we're gonna do now. So we've got this, yeah. Okay. This is P thruster. This is P engine. Thrust left. Okay, so main thruster left is going to be plus lander height. This is okay, so we have these now. VP thrust. This is going to be key W. Rotation. Thrust. Okay. We've got this working. thrust. Okay, so radians from the left. You're getting the... We should hopefully be able to figure this out fairly quickly. It's a 90-degree flip. I don't know if it's plus or minus. I think it's probably minus. Okay. Just do it like this. What's this P? Plus. Okay. Okay, so we apply here. Right and left. Let's see what this does. Unused. Okay, we'll use this. Alright, we should actually get a 3 degree of freedom rocket control apparatus out of this. So this sends us up. Oops. It's definitely applying. Hold on. If I just nudge it a little bit this way, that nudges it that way. And then if I nudge it, yeah, so they're just backwards. Because it should be fire the side thruster. Okay, so whoop, you push it that way. I think that there's still an issue here. So like if I push it this way, it's good. But then once it starts to tilt, let me see. What happens here? Womp, womp. Does this thing need to be clipped? What's the domain of sine? Just input sine. periodic. So it does not need to be in a specific domain. I don't know why I thought it would. Do I need this to be negative? Yeah, there you go. That's what you want, right? Pinwheel. Then on the other side, yep, pinwheel. So, things that we need to do. It actually doesn't take very much work from here if I'm thinking about it. I think that there's some additional mathematics though that were in the original environment that we need to port. Let's get an end-to-end demo with this though. Just have a reset function as well. V2. We don't need legs. Lander ID. We do. Lander. Let's do void init. Lander. Then most of this code actually just goes into here. Lander world ID. And then we do, where's it? Lander barge ID. We can actually do this. Should be lander star env. Then barge. With the body, we have position type. Lander ID, we keep this. Lander. We're going to move this up to the... Move this to the bottom for now. We'll see if we want that later. Then we need a client. Client star make client. Don't need this. Camera 2D camera. just do we allocate client, we assign camera, render. Yeah, this portion is all nice and easy. I think that was literally the only hard part, is what we just had to deal with. Okay, so render, do demo, env, client, env. Just do step the environment. Let's see, where's the step end function? Okay. Just have to move this logic around a little bit. It's all easy. Okay. Just reset. Just a step or a reset, yeah. And this needs to get moved into... These need to get moved. We also need actions now. So let's just do float star actions. We're going to make an allocator as well. Right. This is the init. Yeah, we're going to make an allocator. Reactions. Need this. Allocate lander. Do a init. And then on step, what we get to do is thrust. We get to just assign a force. So float thrust force equal, what is it? Thrust right. And then we can just do like scale side thrust scale side thrust scale. Okay. And then we'll just define these up top. These are not O, these are much higher than this. Okay. And now all we have to do is thrust. Look how simple this is. Here we have action thrust, and now we just do thrust. Get your force, you apply it. Same thing here. Probably don't need this clip, right? Apply the force. This needs to be last one is float action. Is it right? I don't know why this thing does not like to autocomplete in a reasonable way. But whatever. Get rid of this. Just do pop. Env actions be floats, yep. Yep. And then in the binding for this, we can choose whether we want to discretize. It's very funny because, you know, they say in this, oh, you know, one of the reasons we wanted to have this is for true continuous control, but I bet you can do it just as well discretized. It's not that hard of a problem. Okay, there's the step function. As for our render function, we're going to just keep this for a second. We're also going to grab this. We'll play with the RL engine. Depends how fast it is. I'd be very mad if I do all this and its box 2D is still slow. It really shouldn't be. I'm pretty sure writing like slow C code is illegal or something. Just can't be done. Okay, let's see what I need to clean up in here. Ay, 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 ay. Ready is undeclared. I do declare. What's happened here? Okay. Oops. What's happening here? And they're like is there a mess up? Rest scale. Right. Still no? This rebuild? Wait, what are we calling here? Demo? What happened here? Yeah, lander. Yeah, this debugging loop is incredibly easy. Here is our environment. And when we render here, we can have some fun. Because that's pretty easy to do now. Yeah, watch this. Oops. What happened here? Alright, look how easy this is. Maybe not. Hold on. Actions. Thrust scale too small? So here we have this. Should probably draw the circle, huh? We'll handle that in a second. As soon as I fix this scale. I think it's one more. It's 1,000,000. Yeah, look at that. Woo. Ah, I know what it is. Yeah, that's really easy. See? Yeah, I'm landing a rocket. Uh-oh. Guess I'm not landing a rocket. What's the degrees? 0 degrees. Let's see what we do for reward here. We also have to have a better reset function. Maybe we fix that first. Set transform. How does this not have any B2 body? Position, rotation. Okay. Look at that. Just do int tick. We'll just do tick is 0. So we can set this on reset. It's 0. Then on step, we do so we add in some RL standard stuff. And now we need to do reward. And observations as well. And done. And we need to define compute observations. Let's see what they gave in this rocket originally. State. Okay. So this is something we can use. Yeah, we got to do B2 transform, B2 rotation, to rotation. We have figured out how to get all these different variables. Let's see. So we start with position. That's not bad. X plus y. We do velocity. Y. And then let's see what functions they call. Angular velocity. Cosine and sine. Get angle. I think I have it up here. Here it is. How's the Musk rocket going? Well, we actually got some progress on it. We have a very basic thing that has two side thrusters and a main thruster. We're going to turn it into an RL env, and then we're going to actually fix a bunch of the math so it's like somewhat reasonably realistic. Very loose description of realistic, but we're going to take a look at some of the math that's in here on that. The main thing is that I hope it's fast. If it's fast, everything else is easy. I put a very, very high premium on speed. I will say. And then we need angular velocity, I believe. Do you think they used RL? I don't know, maybe. I don't think that the hard part about rockets is getting the is that like it's a hard continuous control problem. As much as it's just like it's a fucking rocket and there are a million things that can go wrong and you don't exactly get to test it a bunch of times. You kind of have to get it right. And for once is indeed rocket science. For once it is indeed rocket science. Yeah, but rocket science and simulation's pretty easy because we don't have to pay like millions or billions of dollars to try the thing. We can just run it. Like if basically right if you could just solve the problem in like a fast simulator and then know 100% that if you solve it in the sim you're good in the real world, it would be easy, right? The hard part's all the stuff that can go wrong in the real world. Send them Puffer to get the 1 million. We will catch a rocket with 2 chopsticks. Oh yeah. uh. Musk has been adamant. What? That comment makes absolutely no sense. He literally like started OpenAI and now has another AI lab with 100,000 GPUs and multiple companies that use AI and do AI research. That makes no sense. Pretty sure OS level AI. Well, yeah, there's some stupid stuff going. Like, there are some stupid things going on with like a kernel level. It's yeah, there's some stupid stuff with that nobody cares. Like, nobody wants that stuff anyways. I got that wrong. Is it the same? No, like, but Elon funded OpenAI originally, and then they decided to not be an open source research lab. They decided to be a closed source for profit lab. Like, you can go read this story. Like, I mean, I spent OpenAI, to be fair, was really freaking cool in 2018 or whatever when I was there. They still do good work. It's just, it would be nice if they publish more of it. But if they just said, yeah, we're a company, like, we got to make money now, we're burning a hole in the pocket, I'd be like, cool. Right? Like, they're like, oh, we can't release it because safety is bullshit. Handful of functions for each new environment must be defined. No, this is me just defining random shit. None of this is required. I'm gonna make the binding right now, Tim, you'll see. Stop getting distracted by silly things. Let me make sure this actually runs. Okay, this runs. What the fuck happened? Oh. Okay, so Now we get to stuff that we actually define for Puffer. We define the observation space. We define the action space. We'll start with this. For an interval. Then all we need is terminals. Oops, we do need tick. Okay, reset. Step. Episode length. Perfect. Okay, so here's our little Python binding. This is like actually incredibly easy to do. So here we have our type def struct. Just put this in Python real quick. Type def struct client. Init. Do. Okay, we make these environments, client, buffer, don't make any of this garbage. Patients, action towards terminals. We also want truncations for this one. And we also would like to have nomads. Okay, we have the client. Get lander. Allocate log buffer. And that's pretty good. Gotta go grab logs. We're gonna want some logs for this. This is a pretty standard little piece of code that's very easy to port over. What do you mean land as rockets? It's a meme. We're doing a rocket landing environment in reinforcement learning. So we have a physically simulated little rocket landing environment and that we're building and solving with reinforcement learning. Yeah, exactly. Yeah, Tim, there's a little binding for it. It's pretty simple. Cool, cool. Yeah, we're getting decently close to having something, I'd say, as well. Can I see it? I'm in the middle of editing it. Here, I'll show you the cool-looking version that we had before. This one will look like this is too once we jazz it up a little bit, I'm pretty sure. But, like... So here was this original that somebody wrote like 7 years ago. It's really slow. We got it in Python, like rendering, kind of. And now we're porting it to run in C. It'll be way faster. How long you been coding? How many years? It depends when you consider coding seriously. Anywhere from 11 to 15 years. Single prefix. Tim, it's because it's an old API compatibility thing. The full observation space is defined for all the agents at the same time. The single is for one agent. So because the environment is vectorized, you have to have both. Puffer tries to make it easy on you, though. What's the best way to get better? Well, the best way is to do it and not to get distracted by, like, ignore any, like, design patterns, object-oriented programming, functional programming, like, frameworks. Ignore all the noise and write cool stuff in the simplest way possible. Also use LLMs to learn to code. Don't use LLMs to think for you for writing code. There's the other thing. We didn't have that problem before. Like, just make whatever I want. Yeah, make like little projects that you can actually complete at your skill level in a very reasonable frame of time. Do a project you can complete in a weekend, right? Do a few of those. Then do a project you can complete in a week or two. You can literally make whatever you want. That's the cool thing. And oftentimes these things end up being really valuable. Like, it's the only field in the world where you can just make whatever the hell you want. Literally. There's no other field in the world where you can just, like, make whatever the hell you want without having to have stupid amounts of resources. I can just be like, yeah, I think I'm going to revolutionize your scientific field of reinforcement learning, and you can just do that. Are you in college? Nope. Out of college, out of PhD. I am a newly minted MIT PhD. Graduated this last spring, and now we're doing full-time reinforcement learning. Puffer AI is technically a company. I'm doing full-time reinforcement learning development. I can technically make whatever I want, though it would probably be a good idea for me to do stuff that's reasonably in line with what I'm trying to do with Puffer as a company, so that we actually get some clients. No, I don't just do completely random things. It's all kind of in the service of making this tech stable and solid and useful for people. Do you know game dev? Yeah. All these sims are basically like writing games. Here. I made this little stripped down MOBA for reinforcement learning. Runs really fast. And train agents on it. So yeah. Thanks for dropping by. I've used engines before, but I'm usually writing stuff from scratch for the most part. I've used engines, sure, but like a lot like here, this MOBA just uses Raylib as a renderer, and like the logic doesn't have an engine, it's just all in C. Yeah, learning an engine is kind of different from learning how to program, I will say. Um, there's a lot of fluff and things that you may or may not want to be thinking about. How do you think like a programmer? By programming a lot. By programming a lot. I mean, there are some things if you like stick around like people that know what they're doing that you can potentially learn faster and save yourself some mistakes. But it will take a long time regardless. Like frankly, a lot of the AI stuff I do took less time to learn and get very good at than just general purpose writing good code. Okay, we got this. We gotta add logs here, I think. Yeah, we got this. Okay. By rocket lander. Ocean. Rocket lander. What are rewards here? I haven't defined them yet. They'll get some rewards though. Hmm. Oh. We gotta do by rocket lander. This is when we actually get to move fast and like fix things quickly, which is the much more enjoyable part here, you know? Not a type identifier. Really? I guess I gotta link some stuff, don't I? So we do. There's no lib, is there? Hold. First, gonna do this. Figure out, so library dirs. This better? Did we get the thing linked? No. Why is this not linked? There's no library dirs. There's gotta be a, should I just go look at how Box2D itself does it? Well, no, because they're not gonna have Python, I'm assuming. Let's fix the other ones first. Oh, also, all this. What's wrong with the rocket lander? Whoops, this is lander. Log buffer. Lander. Yep, so we need to take these fields. This process could definitely be simplified at least a little bit. Truncations. Reward terminal truncation. Cannot assign unsigned int. That's fine. So this is where we do a little cheeky discretization just to be just to play around. So we do self.actions of $0 actions equal 1. This, so a little discretization. Type unsigned float. Semi-obnoxious. We'll do the discretized version first. It's an unsigned int here. Oh, I know. New environment shenanigans. Okay, cool. Now we actually get to the correct, the actual errors. I will be right back. I'm gonna grab tea, and then we just have to figure out how to link, compile and link box2d correctly with Python, and we should be set on this, and we'll be able to train some stuff. Okay. What is wrong with box 2D? I don't need these on. Why do I have these on? Let me see. So we have the include dir here. There is no library dir, really. Runtime, including box 2D. Maybe there is, maybe the library does have it. Hold on. Was the setup? Extension. Let me see, maybe they just have it here. Box 2D. Box 2D source files. Okay. Extra compile args. Extra args. Dash I. There's like literally nothing there. Also, this is C++, which is weird. IX, numpy get include, box2d include, source, box2d, build slash source. libbox2d.a. That looks correct to me. Will we get what am I missing here? Did you finish the MOBA thing? We have a version of it with some improvements from before that is online. There will be some more on it for sure. But we have, you know, the ability to train some agents, and it's pretty fast. Lots of stuff in there. Currently fixing up just a quick, like, 2-day project, this rocket env. And just have to figure out how to bind. I don't even know if this is it, because is this the same code? I don't even know if this is the same code. So weird that, like, prelude slash include, x2d slash include. It should be able to get this. Do I need a different flag or something? Source files. No, there's a make file. Oh, maybe we do need to do... So obnoxious, though. Trying to think how I want to deal with that. Yeesh. Gotta have box2d, build source. Didn't it just give me my original? It's literally what I have. So this should be correct then. Okay, I do. Oh, do we need to just get rid of this? Because this shouldn't be needed, because it's static, right? Do I need to do... Well, this should build extensions. What the heck? Why is this so finicky? This should just work. Right? This should just work, yeah? What do I do for this? I do box 2D, include, and then this, right? Do I not need this? No, I do need this here. Link static C. Objects. Do you need extra objects? That doesn't seem to help. Source files list. Dash static. I shouldn't have to do any of this shit. Like... Let me see what the command is that it's outputting. Is it not? Wait, it might not be. Where's the bloody command? Error compiling Python files. cdef extern from. Oh, do I literally just need to do c type def struct v2? Dude, this is just disgusting having to do this. And these should be able to be auto-generated. uint 8t. Okay, let's see what this does. Probably shouldn't have put those into the struct. I don't know why I did that. It's kind of stupid. Too many indices. Array is one-dimensional, 2 were indexed. Nums. Point. Okay. for AC. Well, that's obnoxious. Let's just take the opportunity to correct a couple of things, eh? We'll just do, this will be a float. This will also be a float. And then all we'll do is self.float actions is just going to be like this. Mems 3, so float 32. We'll pass float actions instead of actions. And then we'll simply do self.float actions. And we'll just sync the buffer manually this way. Pretty easy stuff. And then we have, we forgot to delete some print statements, apparently. F. So we'll remove that. And there we go. Immediately, we already have something running. We can make this much, much faster. Doing maybe 5112. Let's do 32K. Mini batch. Oh, interesting. That's funny. I forgot about that. B2 max worlds. Uh, 128 times. Yeah, we'll do 16. We might have to mess with that. 35K. We'll also be able to multi-process this, presumably. Maybe that'll get us to have more. Let's figure some things out, though. Okay, so what we do is episode length. Tick, like this. And then we need to think of some rewards. Let's simply give you probably need to go get like velocity and stuff, right? Angle. Actually, it would be kind of good to have reward computed here. And the reward. Because we already have the stuff we need right here, right? So we'll just do float reward. F, apps, F. Come up with some stuff. Hi. Okay, and then we'll just do env log, so return plus equal reward. How long should logs take? Do reset. What's happening? Tick. Oh, right here is the issue. Maybe faster now. There we go. So length, episode return. This is going to end up being a decent prototype. Okay, reward scale is off. $1,000. This can be over 2,000. Episode reward is too crazy. I think we simply do x is less than negative 500. There we go. $1,200. Just putting like we're just hacking some basic safeguards onto the end. Is all we're doing. Still, rewards way too negative. We also need to just reset the reward at the top, right? Let's do that. Didn't recompile. Let's see what's going on here. X position can be over 5K. Y position can be over 10K, I believe. And the rotation, pi over 10, maybe. There. It's more reasonable range at least. Alright, cool. Now we just have to play it and debug the rewards a bit. Right? Demo. So here we have our rewards. We can see that this reward goes down. Right? If you thrust, your negative reward goes way up. If you continue to do this, Seem that this is fairly reasonable. Do this. Forgot to comment that. Okay, let's see. Doesn't look particularly happy. Actually confused as to how it gets this bad of a score. Because I couldn't figure out how to get it to have that bad of a score. So let's see. So we have 0 or 1 for all of these. Some of them are all zeros, right? So that's pretty good. There you go. Probably need to norm these things. Let's see, over 500, over 1200, and norm some stuff. Mm-hmm. Mm-hmm. Ooh. What do we do, 1,000? Oh, that's too much, isn't it? Wait, no. 200 some odd K? Yeah, we're good. So already the episode length is insane. Rewards. Okay, so we can see that we have rewards that are what we would expect. Observations.max 1. Observations.max. Okay. We actually did a decent enough job with this normalization. Looks like we probably should have done these velocities a little higher. But what else? I don't think we ever set terminals, do we? No, we don't mess with these, which is fine. We don't have to. We would stop getting logs if that weren't working. Let's see. Okay. One more. Rewards gotta be nutty now, right? Well, these rewards don't make any sense here because these don't look like rewards that are that bad. Oh, wait, are we just not clearing our nice logs out? Hold on. I think we're just being stupid. Uh-oh. Alright. More reasonable scale. Box 2D Max Worlds. Huh. Radians. There's like an upper limit. That really needs to be fixed. Um, is there any reason for this? This is like stupid, right? Can we just do like... Hold on. This. Oh, didn't I have to build it static? Oh, we'll see in a second. Yeah, okay. Team build. October 15th. Yeah. Have to recompile. Just copied. Hold on. Dot. Add trigger recompile. There we go. Haha. Completely arbitrary limit bypassed. No, you're not allowed to allocate more than 128 worlds for no apparent reason. Me. Done. Okay, Rocket Man. Let's try this and 131. Let's try this. $82K. It's better. Value loss is too big. It's decreasing. Probably just learning rate is too high. Something like that. Interesting that it is decreasing. Hey, Spencer. We're landing rockets. Tempting to, at least. Now, reward gets worse, which is awkward. Let's see if we can watch this. Ooh. Right? Let's see if we play it. Let's see if we play it. We do better. The thing is, I'm pretty sure the default should be... Like, you should be able to do well literally just by not pressing anything until we add the randomizations. Okay, so here is our rocket lander. Whoops. Environment. You can see the reward is actually very reasonable. And if I, like, start pressing shit, reward goes up. I mean, reward gets worse. It would seem like it should just be able to not learn to not do anything. See if there's a reason it can't. Yeah, it should. So something is screwy. Let's see what happens if I do this. Interesting. Why do we need to get fewer logs? Oh, no, that's fine. Negative 19. That's what it should be able to learn. Both actions. It's got single action space discrete. Self rewards. Yeah, it should learn this like instantly, so let's see what's wrong. Hmm. Data's in a decent range. Actions is 1. Oh. Wait. Oh, it gets cleared. When does it get cleared? It shouldn't get cleared. Oh. Yeah, there's no reason to do this. Possibly even messes some stuff up. Oh, let's do self dot equals. Okay, literally just training it to not do anything. Can't learn. num_ems. Give it ops action terminals, num_ems. Init lander. I. How's the value loss that? Crazy. No, value loss can't be that crazy. We missed something? Oh, you know what? Hold on. I bet we've got data bullshit. Oh wait, no. Still not optimizing? That's crazy. That is crazy. Oh, is it doing something? There it goes. Alright, learning's not completely broken. Kinda slow. And we just make it fast and then see if we can optimize. We do 2 ems, 2 workers. 4 workers. We should actually keep that task. Boom. 200K. Yeah, we can do even faster, I think. It's just a matter of how many M's we're willing to run. 200. We should make sure we can actually learn with this. And then we run sweep. Does free compile? Oh yeah, there it goes. Now it optimizes. 42. We just run a little sweep on this. Something like that. Shouldn't be hard, right? 20 mil, something like this. I would hope this is enough to learn to not do anything. Cool. I'll be back in a bit, in a few, and we'll see if it's figured anything out by then. I'll be right back. What's going on? What's going on here? Are we, OMing or something? What's up with Juan B here? Hello. How's it going? What's carbs? Alright, we have one experiment. Oh, okay, so it actually, this thing came back. For some reason it seems to not like to relaunch. We probably need to do a cleanup function of some type. This one worked, though. This one worked. We can probably do way better. Let's figure out what happened. I'm assuming we just need to make a close function. Yeah, that's probably it. We just need to properly clean up after the environment between experiments. We don't need to free this. Lander. And then we need to, like... How do we clean up after it? Clean up. When you are done with the simulation, you should destroy the world. What a line. We actually have to call this on each end, don't we? Something like this. Do we actually call close? We do. Alright. Let's see if this does it. Actually, we should run a shorter sweep. This should not take 20 million time steps. So this is the sanity check to get some reasonable enough hyperparameters that it can learn to literally not do anything. And then after this, what we're going to do is we're just going to like push the rocket a little bit at the start. And we're going to see if it can learn to right itself. And then hopefully I'll be done for the day after that. What's going on? The heck? The heck? Just know, join stream now. Trying to create a rocket lander game that's controlled by AI. Kinda, yeah. Let me see if I can find you the... Something is really screwy with this. It's not handling, For some reason, it's not letting me tear down the experiment and make a new one. Here, let's see. It might be a box 2D limitation, actually. But what we're trying to do is... I posted it before. So here's this old rocket env that somebody made. I'm trying to port it step by step. I'm trying to port it to C, so it'll be way faster. I got it working in Python, but it was too slow. So we're now trying to do the same thing in C. And it's been difficult, but we have like some basic version of it that we can start with now. And we're essentially trying to figure out how to train some models on it with Puffer. Basically, with Puffer, the deal is as soon as you get everything fast and as soon as your experiment setup is right, Puffer will just do everything for you. So I'm just trying to get it to that point. Puffer will just go swimmingly. Let me try something real quick. It's just... I think this is a box 2D screw up. Okay, so this should just be like some gigantic number. Yeah, let's just do this. That ought to at least let us run some experiments. Box 2D has this really weird thing where it likes to prevent you from making too many instances of itself. U16 max, okay. So that's a little awkward. What's max U16? 65K. That should let us do some experiments at least, if this is the issue. I don't know why they would use a short for this. Silly library. How is that greater than... Oh, -1. Yeah. When training this AI, it must know the code input controls that a player would have. It's more like player controls, yeah. It doesn't know the code or anything. It just sees it sees how fast it's moving. It sees where it is. It sees like its rotation and stuff, and it gets rewarded or penalized based on how it does. It's kind of it just learns by trial and error. More intelligent than trial and error, but reinforcement learning. We're currently fighting to get this. I mean, the funny thing with Puffer, like the RL tech I build, is like the RL is actually really good. What is it? Actually, here we'll just do 65. Yeah, that'll just work. The funny thing with the RL is that it's actually very good, such that when you get everything set up reasonably, it'll kind of just automatically solve it for you. The tough part is getting everything set up cleanly. That didn't used to be the case. It used to be the case that even then, the RL was a nightmare, but with Puffer, it's very easy now for a lot of problems. Okay, cool. So we actually got this built. Now let's see if let me see if I'm right, if that actually lets us run some experiments. So this is now running 200,000 some odd steps per second. This is literally not 1,000, it's 100 times faster than I had it in Python. We'll see if it lets me cleanly start a new experiment. I'm curious to see. That's what RL means. Cool. So you will make normal game, Puffer will run and train on top. Very beginner. There's a little bit more that you have to do than that. You can't just get like a game binary. You have to format the data in a reasonable way. You have to define a few additional things. That's a lot of what I do with Puffer, is making that process easy. It's not just games either. It'll work with lots of different types of simulations. So that's what I'm doing at the moment. And yeah, it looks like I fixed that bug, at least temporarily. So what it's doing right now is it's automatically running several experiments in order to find good settings for itself to be able to solve it more quickly. And then based on that, I'm going to make the problem harder. I'm going to like flick the rocket a little bit so that it has to actually write itself. And then we'll rerun it and see how it does. Unfortunately, I think this is only going to be able to run like a few experiments before it hits that bug again in box 2D. I wonder how hard it would be to like mod box 2D there. The limitation is kind of silly. Maybe this will be good enough for now. So, I mean, we might have gotten lucky with this set of parameters. It might take us a second to find a better one. But here we have this nice dashboard. You can see that we have a few experiments going. And we will get to see various outcomes of these experiments with associated graphs. And it'll just run these for us. In a few minutes, we should have something reasonable. We will go from there. What's the chance this is spam? No idea. Cool. Box 2D thing can just be restarted for each run. Yeah, kind of, except that the way that we do our experiment harness, like the way that these sweeps run, you don't get a fully clean setting every time you run. And like for some reason I don't know what it's doing. It's like caching number of worlds created or something weird. It's very silly. It also, they just like arbitrarily limit it. So like they wrote this whole engine and then they have hard coded. There's a constant in there that says you can't simulate more than 128 worlds at the same time. With Puffer, we want to train on thousands at the same time. Really, you're kind of just trolling if you're going much slower. Okay, so here we have episode return. It's very weird how this one actually, previous one here worked. Can't you run the simulations on different processes? We already have them on different processes, but we're starting like 2,000 per process, so eventually it'll catch up. I mean, this is just silly. Like, you know, I can probably just mess with Box 2D and like find and replace that short with an int, and then we'll be good. Maybe I'll just send him a PR. But like literally just while I've been sitting here, I mean, we've got all these experiments that have run. I'm curious actually what this one did, because this is kind of funny that like the first experiment I did looks like it's solved. It's a very basic task. It shouldn't be hard to solve. interesting. Guess it came up with some parameters. We'll let it run a little longer, at least while it's going here, and we'll see if we get anything interesting out of it. But I mean, I'm running this on my local desktop, not even on one of my good machines. Hey, Bet. I didn't realize I've been live 5.5 hours. We got some stuff. Been alive, good. Like a little rock stopping a tank. Yeah, it's very silly. You should have seen the stuff I got stuck on earlier today. I had like an absolutely terrible morning debugging this janky physics and rendering. But we got it to like mostly do something reasonable. And now it's just like matter of what's going on with it. No Mechazilla arms, dude. I like friggin' the physics thing is obnoxious. The physics API is very obnoxious. We literally just have like a box now. But we have side thrusters and we have the bottom thruster actually working now. Very weird how this is. Episode return. Check going on episode return, right? Literally the first experiment that I'd run had solved. Unless there's something totally wrong with this. Yeah. I might need to change some hyperparameters. Because a lot of these aren't working. And this is a very basic test. This is literally like, I mean, they just need to learn to not do anything and like drift slowly to the ground and not like hit any of the thrusters and get it off center. This one's very, very easy. It's gonna get much harder after this. Got it discretized as well, so it should be very easy. Yeah, thanks for the advertising, Bet. It's, all the stuff I'm doing here is free and open source. You can check it out here. And if you like what you see, feed the Puff for a star. Helps me out a ton. There's also some of our M's online. You can play them. This is the most complicated one we have at the moment on here. It's actually kind of fun that, like, I enjoy playing this thing. Some of the abilities actually feel better to use than the ones in, like, real games, which I find amusing. this tank. Hold dev in their raylib. Did you recompile? It could be that you have old raylib folders with the same name that have the wrong stuff in them. Because in the latest, it should literally just pull down all the raylib stuff for you. See if you have old folders that are named like raylib. If you have an old folder that's named raylib, that could mess it up. No, it was fresh. Does it make raylib for you? Like, does it install raylib? You should get a raylib folder. Gave it a star. Thank you. Yeah, it's relatively easy for... If you have like a solid programming background, we have new people that have never done any AI that have been like building useful RL environments that run crazy fast. Because it's kind of just like low-level environment games or simulation programming for the most part. What env doesn't work with raylib issues, Bet? Dev should be pretty easy. I mean, there could be some stuff broken, but it shouldn't be. I'm also very confused as to why it can't solve this all of a sudden. Should be able to solve this by now. None of them compiled. None of them actually compiled properly. Here's local MOBA. That actually is such a fun mechanic. The dash strike is really funny. I run them. Well, those files are named wrong, so I'm assuming those are old. Because it should compile it to the root directory as just like /connect4. So you probably have old files. If you recompile the new one, it should run. Because that error isn't possible anymore, because raylib is linked statically. So if it compiles, that's not possible. You don't need to run with LD library path or anything. It's linked statically. I'm very confused as to why this thing is not training when it trained previously. And this should be a very easy task as well. I mean, it is technically getting better, but like, this should be very, very easy. Wonder if it's possible that the worlds aren't resetting correctly or something weird like that. Fox 2D is a little weird. I mean, these curves are like suspiciously similar. Like, why do they all dip like late in training? They definitely shouldn't have that same sort of shape. No, you think, Bet? I could take these params. I could just take these and see if these do it. Let me see. Because these seemed like they did it. Let's just start on this while I'm waiting. I like big batch.